ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ರಿಮೈನಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ Lagrange's linear PDE ಮೇಲೆ. So the first problem we are going to consider in this video is solve y minus z into p plus z minus x into q equal to x minus y. The solution: given y minus z into p plus z minus x into q equal to x minus y. So comparing this with PP plus QQ equal to R, we get capital P equal to y minus z, Q equal to z minus x, R equal to x minus y. Now we have to write this in the form dx by capital P, that is dx by y minus z equal to dy by z minus x equal to dz by x minus y. Now see, suppose we consider this pair, then you get z minus x into dy equal to y minus z minus x into dx, y minus z into dy. See, this involves z, this involves also z. We can't apply separation of variables here. If you have only functions in x in one side, only functions in y or z on the other side, then you can apply separation of variables. In this case, separation of variables you can't apply because we don't get functions in one variable one side and functions in the other variable other side. So we have to go for multipliers. So choose multipliers. Okay, I'll recall that also. You have to choose multipliers k1, k2, k3 such that this symbol is for such that k1 into p plus k2 into q plus k3 into r should be 0. So here our p, q and r, such that you have to choose k1, k2, k3 such that p into k1 plus q into k2 plus r into k3 should be 0. See, if you add just these terms, you get y minus z plus z minus x plus x minus y. So z get cancelled, x get cancelled, y get cancelled. So you can choose multipliers 1, 1, 1 such that you'll get dx k1 into dx alva. So k1 andre 1 into dx plus 1 into dy plus 1 into dz divided by k1 into p. 1 into p ಅಂತಂದ್ರೆ y minus z plus 1 into z minus x plus 1 into x minus y equal to dx plus dy plus dz divided by y minus z. Z cancel, x cancel, y cancel, you get 0. So integrating numerator, would you have dx plus dy plus dz. So I'll get integral of dx plus integral of dy plus integral of dz equal to c1. So that is x plus y plus z equal to c1. So this is first function of y of u comma v. So here you got u. Next you have to choose one more multiplier, one more pair of multiplier you have to choose. So we shall take one thing, multiplying x to p, you get here xy minus xz. If you multiply x to p, you'll get xy minus xz. Here you got minus zx alva, so ಇಲ್ಲಿ minus zx ಬಂತು. ಇನ್ನೆಲ್ಲಿದೆ z, ಇಲ್ಲಿದೆ. So here z ಇತ್ತು x ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ x ಇರೋ ಕಡೆ z ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಟು ಮಲ್ಟಿಪ್ಲೈ z. Then you will get, okay, here I have plus xy, I should get minus xy now. X is present here, I can't multiply y to this ಯಾಕಂದರೆ ಇಲ್ಲಿ y square ಬಂದ್ಬಿಡುತ್ತೆ. I can multiply y to this, will get yz minus xy. Next obviously multiply z to this, will get plus xz minus zy. So zy cancel, xy cancel, xz cancel. S. Second set of multipliers is choose multipliers. Choose multipliers x comma y comma z such that x into dx plus y into dy plus z into dz divided by x into y minus z plus y into z minus x plus z into x minus y equal to x dx plus y dy plus z dz divided by, this will be 0. Integrating numerator, so I'll get integral x dx plus integral y dy plus integral z dz equal to C2. So that will be x square by 2, I'll write here, x square by 2 ds, sorry, x square by 2 plus y square by 2 plus z square by 2 equal to C2, or x square plus y square plus z square equal to 2C. The solution is 5 of, see from this I'll get x plus y plus z, x plus y plus z. Another part is x square plus y square plus z square equal to equal to 0. So that is the solution. So this solves first problem we considered here. Next let us consider one more problem, B. Okay, B, C, D, E. See, before starting this problem, I would like to say you note generally we will take multipliers either 1 1 1 multipliers generally. First usually no preference ಕೊಡೋದು ಇದಕ್ಕೆ 1 1 1 or x y z or x square y square z square. Fourth one 1 by x 1 by y 1 by z. So generally we check this. If not, then I have to look for another multipliers. Generally this holds, keep that in mind. So next problem E. Solve x into y square minus z square plus p plus y into z square minus x square into q equal to z into x square minus y square. Solution. So here I'll write directly PQR. Here P equal to x into y square minus z square. Q is y into z square minus x square. R is z into x square minus y square. We have we have dx by p, that is dx by p ಅಂತಂದ್ರೆ x into y square minus z square equal to dy by q, that is y into z square minus x square equal to dz divided by z into x square minus y square. Now I can check that if these terms are removed, x, y and z, then y square minus z square plus z square minus x square plus x square minus y square is 0. So choose multipliers. 1 by x, ಇಲ್ಲಿ ನನಗೆ x ರಿಮೂವ್ ಆಗಬೇಕಲ್ಲ, ಸೊ 1 by x, ಇಲ್ಲಿ y ರಿಮೂವ್ ಆಗಬೇಕು, 1 by y and 1 by z to get 1 by x into dx plus 1 by y into dy plus 1 by z into dz divided by p, k1 into p plus k2 into q plus k3 into r. You have to write k1, that is 1 by x into x times of y square minus z square plus 1 by y into y times of z square minus x square plus 1 by z into z times of x square minus y square. So this will be dx by x plus dy by y plus dz by z divided by 0. Integrating the numerator, I'll get integral dx by x plus integral dy by y plus integral dz by z equal to 0. Okay, that will be not 0, it is c. Okay, c1 I'll write. So that implies log x. Okay, here I'll get log, right? So let us take this as also log x plus log y plus log z equal to log c1. So from this, with simplifications, I'll get x, y, z equal to c1. That is one part of the solution. So next, choose multipliers. See, here we have x into y square minus z square plus, if you multiply x here, see, I'll get x square y square minus z square x square. So let us write that here. If I multiply x to this, I'll get x square y square minus x square z square. Next, if I multiply y to this, see, I have to get same degree. So degree goskara nanu idu ಮಾಡ್ತಾ ಇದ್ದೇನೆ. So y into z square, multiply y again. So y square z square minus z, okay, y square x square. Now multiplying z to this, you'll get z square x square z square minus z square y square. See, these two get cancelled, these two get cancelled. So x, y, z is second set of multipliers. Choose multipliers x, y and z. We get x dx plus y dy plus z dz divided by x into x square minus, okay, this will be directly x square into y square minus z square plus y square into x square minus, so that will be z square minus x square plus z square into x square minus y square. So this you get x dx plus y dy plus z dz divided by 0. That is just a notational presentation there. We are not actually dividing it by 0. So integrating numerator, I'll get integral x dx plus integral y dy plus integral z dz equal to c2. So that will be x square by 2 plus y square by 2 plus z square by 2 equal to c2, or x square plus y square plus z square equal to 2c2. Hence the solution is phi of x y z comma x square plus y square plus z square equal to 0. This is the required solution. Next, let us try to solve one more. A, B, C, D, E aitala. F. Solve x, y, z. Okay, sorry. X times of y square plus z into P minus y times of x square plus z into Q equal to z into x square minus y square. So here solution. This is in the form PP plus QQ equal to R. No simplification needed. Here capital P is x into y square plus z. Capital Q equal to minus y into x square plus z. Capital R equal to z into x square minus y square. We have dx by x into y square plus z equal to dy by minus y into x square plus z equal to dz divided by z into x square minus y square. Now this we can't solve by separation of variables. We had to choose multipliers only. Now choosing first multipliers, 1 by x into 1 by y into 1 by z. Choosing multipliers. See, if you remove x here, remove y here, remove z here, then what do you get? Y square, that cancels with minus y square. Z, that cancels with minus z. X square can cancel with minus x square. So I have to remove x, y, z there. So I'll take 1 by x, 1 by y, 1 by z. Then we will be having 1 by x into dx plus 1 by y into dy plus 1 by z into dz divided by x cancels here, so I'll get y square plus z minus y cancels here, minus x square minus z plus z cancels here, x square minus y square. So x square cancel, z cancel, y square cancel. So I'll get dx by x plus dy by y plus dz by z by 0. So integrating numerator, I'll get integral dx by x plus integral dy by y plus integral dz by z equal to log ಬರುತ್ತಲ್ಲ, so log c1. So this will be xyz equal to c1. So that's about first part of the solution. Next, see here the degree of these terms is 2, x square minus y square you have, but here you have x square plus z, here you have y square plus z. So we'll do one thing, multiply this 2 by x and y, then cancel this z. I mean cancel ಅಂತಂದ್ರೆ ಅದನ್ನ ಹಾಗೆ ಇಟ್ಕೊಳ್ಳೋಣ ಅಷ್ಟೇ. Choose second set of multipliers. choose multipliers x comma y, and ಇಲ್ಲಿ ನಾನು y ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ದಿಸ್ ವಿಲ್ ಬಿ ಮೈನಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಎಕ್ಸ್ ಸ್ಕ್ವೇರ್, ಬಟ್ ಇಲ್ಲಿ ನನಗೆ ಮೈನಸ್ ವೈ ಸ್ಕ್ವೇರ್ ಇದೆ, ಸೊ ಇದು ಪ್ಲಸ್ ಆಗಬೇಕು ಮತ್ತು ಝೆಡ್ ಆಗೇ ಇರಬೇಕು. ಸೊ ಪ್ಲಸ್ ಆಗಬೇಕಂತಂದರೆ I have to multiply minus 1. Then so we'll be having x dx plus y dy minus dz divided by x cancels, so we'll get x multiplied x square into y square plus x square z minus y square x square minus y square z minus z ಆಗಿರುತ್ತಲ್ಲ minus zx square plus zy square. So plus x square z cancels with minus zx square, x square y square cancel x square y square minus y square z plus y square z. As terms get cancelled, you will get x dx plus y dy minus dz divided by conventional notation it is. So integrating numerator, we get integral x dx plus integral y dy minus integral dz equal to c2. So x square by 2 plus y square by 2 minus z equal to c2, or x square plus y square minus 2z equal to c2. So the solution is, hence the solution is phi of x y z ಮತ್ತು ಇದರಿಂದ x square plus y square minus 2z equal to 0. So that is the solution. So that completes the solution of that. There is one more equation. Solve x square into y minus z, okay, x square into y minus z p plus y square into z minus x q equal to z square into x minus y. Solution. Here p is, capital P is x square times y minus z, capital Q is y square times z minus x, capital R is z square into x minus y. We have dx by x square into y minus z equal to dy by y square into z minus x equal to dz by z square into x minus y. If I remove this x square, y square, z square, see, you get y minus z plus z minus x plus x minus y, which is 0. So the first set of multipliers is, choose multipliers 1 by x square, comma 1 by y square, 1 by z square. Then we get 1 by x square into dx plus 1 by y square into dy plus 1 by z square into dz divided by 1 by x square, x square cancel ಆಗುತ್ತೆ, you get y minus z. Simply I'll write terms after multiplying multipliers. So what do you get? X minus y. That is, so dx by x square plus dy by y square plus dz by z square divided by 0. Now integrating numerator, I'll get integral dx by x square plus integral dy by y square plus integral dz by z square equal to constant. Let us write c1. We don't get log here. So integral of 1 by x square is minus 1 by x. Integral minus 1 by x minus 1 by y minus 1 by z equal to c1. Or 1 by x plus 1 by y plus 1 by z. Okay, I'll write this here only. Or this is equivalent to 1 by x plus 1 by y plus 1 by z equal to minus c. So that is first part of the solution. Next I had to choose one more set of multipliers. So let us choose 1 by x, choosing multipliers 1 by x, 1 by y and 1 by z. We get 1 by x into dx plus 1 by y into dy plus 1 by z into dz divided by x into a y minus z, multiplying that 1 by x. I am writing that product, y into z minus x plus z into x minus y, which is dx by x plus dy by y plus dz by z divided by the notational convention, that is 0. So integrating numerator, so I'll get integral dx by x plus integral dy by y plus integral dz by z equal to constant log c2. So that implies log x plus log y plus log z equal to log c2. So x, y, z equal to c2. Hence the solution is phi of 1 by x 1 plus 1 by y plus 1 by z comma x, y, z equal to 0. So let us take a few examples as exercise. So try to solve this one. Xz into dou z by dou x plus yz into dou z by dou y equal to xy. See, keep in mind that P stands for dou z by dou x, Q stands for dou z by dou y. So they have not given explicitly here P and Q in terms, they have given in terms of partial derivatives. So try to solve this one. You have to get the solution. Phi of x by y, separation of variables you can use here, xy minus z square equal to 0. Similarly, let us take one more. mz minus my into p plus nx minus lz into q equal to ly minus mx. Try to solve this one, and let us take one more. So again you can apply separation of variables. So the last one, you can apply separation of variables easily. So 3 y plus z into p plus z plus x into q equal to x plus y. Now try to solve these three. With this we are going to wind up the discussion on Lagrange's linear PDE.